Hello, good morning, and welcome to Nature Live Online from the Natural History Museum. I'm Khalil Thirlaway. If you're new to Nature Live, this is a series where we have conversations with researchers from the museum and beyond, telling interesting stories from their work in all sorts of fields, from dinosaurs to DNA, volcanoes to vampire squid, and much more. Now, we really love hearing from you at home as well, so if you've got any comments or questions, please do pop them in the comments section down below, and we'll come to as many as we can in the time we've got. Today, though, it's Friday the 13th, and we've got a suitably spooky story for you. We're delving into a mystery surrounding a grave full of mixed up bones found in London a few years ago. To help unravel this story, I've got two guests with me today. Archaeologist and a heritage advisor at the Canal and River Trust, Phil Emery, and mammal curator at the Natural History Museum, Richard Sabin. But first, we're going to get a bit of an intro to the story from Phil. Hi, Phil.
Good morning. Thank you very much for inviting me.
So, where does this story start?
Well, in November 2007, St Pancras International, the London terminus of High Speed 1, was opened. And that was the culmination of a very long and complex construction project. And as part of that construction project, there was a program of archaeological work. And one of the main projects took place at St Pancras.
So what were they doing here?
Well, to accommodate the very long Eurostar trains, they're some 400 meters long, the platform decks had to be extended. And this brought the station into the area formerly occupied by the churchyard of St Pancras.
And I guess this poses a little bit of a conundrum for a project like this, because it's a really big infrastructure project that everyone's committed to, but at the same time, we've got to treat these graves with respect. We don't want to just kind of build a train station on top of them. And there's also a lot of archaeological and academic value to studying this burial as well. But at the same time, these are still people's graves.
Absolutely. The whole project was controlled by an Act of Parliament, the Channel Tunnel Rail Link Act of 1996. And as part of that, the methodical recording of archaeological remains was an integral element. And for the investigation at St Pancras, a team of archaeologists were in attendance during the work of a cemetery exhumation specialist. And I oversaw the team. So we had a team of field archaeologists on site undertaking the recording of burials, and some 1,400 burials were recorded archaeologically. And there was also a team of specialists off-site, including the Museum of London Specialist Services. And they were tasked with examining the human remains and artifacts associated with the burials.
And during this excavation, there was one grave that particularly stood out. Why don't you give us a bit of context to that?
Well, the burial ground was very interesting because we could see the changing pattern of burial, the way that the management of the burials was happening. So in the early years, from the time when the burial extension was made in 1793, the graves were quite conventional. They were discrete grave plots with successive burials laid one on top of the other. But later on in the life of the cemetery, around about 1822, and I'll come back to how we know that date, we see a very dramatic change in the pattern. And so rather than discrete grave plots, the burials are laid in open horizontal trenches where the coffins were laid very tightly, packed almost like sardines, head to toe, in horizontal layers. And these were mass burial trenches.
So why do we see this transition from kind of traditional stack burial to just this big trench full of coffins?
Well, I think to answer that question, we need to stand back and think about what was happening to London at the time. So in the late 18th century, St Pancras was a rural parish in Middlesex. way out of the built-up area of London. But around about the beginning of the 19th century, London was undergoing a very intensive process of dramatic expansion and industrialization. So not only was there a massive influx of population as part of the industrial revolution and the sort of socio-economic changes that go along with that, but you also have a rise in mortality associated with urbanization. So the diseases that affected people living in a densely urban area.
So London grows really fast, engulfs this little country village of St Pancras, and then suddenly they've got loads of people and they keep dying and they need somewhere to put them.
Yes, and I think that's very reflected. That's reflected very graphically in our three-dimensional model, which shows the intensive overcrowding of the burial ground. And there are contemporary engravings, for example, a wonderful one in 1853 showing three simultaneous funerals with a very densely packed cemetery behind.
So in this kind of tightly packed sardine tin of coffins, as you described it, which one is the grave we're talking about?
Well, I think we can annotate the model with the red arrow there. That's right. So what you can see there is a coffin that is lying in the uppermost layer of one of the mass burial trenches. And we know that the graveyard was eventually closed in 1854. And as I say, the transition from the conventional style of burials in discrete grave plots to these mass burial trenches takes place in about 1822. The reason we know that is because the very clay ground conditions led to wonderful preservation of the coffins, the human remains, and also artifacts associated with the coffins. And one aspect of the artifacts were the coffin plates, which were attached to the lids of the coffins. Now, these coffin plates were thin sheets of iron coated in tin, and they were designed to be shiny for the period of mourning. But remarkably, they were still legible when we excavated them in 2002 and 2003. And therefore, we were able to decipher the names of the interred individual, the age, the sex, and the date of burial.
So you say interred individual, but this coffin we're talking about, it's a bit more complicated than that, isn't it?
Yeah, so nearly all of the coffins, as one might expect, contained the skeleton of a single individual. However, this coffin was quite different. We found in this particular casket the remains of some 8 individuals, including 3 skulls that, and of which you can see in the top left picture there, is one of them, and other skeletal elements, including the one on the top right.
And these bones, they look like they've been kind of cut or drilled, right?
Absolutely. Every one of those bones showed signs of cutting and manipulation with a sharp implement, probably a scalpel. So these have been prepared for either study or display. And
so we've got these kind of this collection of dissected human remains, but those bones on the bottom of the image, they look a little bit malformed or different.
Yes, at first glance, you might be forgiven for mistaking them for human bones, but very quickly the specialist osteologists at the Museum of London identified these as not being human, and they were handed over to the faunal remains specialist, Alan Pipe.
And Alan brought in a little bit of extra backup specialist help from the Natural History Museum, from Richard Sabin. So we've got Richard joining us as well. Hi, Richard.
Morning.
So this is where you enter the story. So what happens? Alan Pipe just calls you up and says, I've got some cool bones to look at?
It was one of those things that you hope is going to happen at some point in your career. And fortunately, working at the Natural History Museum, it happens quite a lot. But just to give it a bit of context, the expertise that we've got at the Natural History Museum and the research collections means that we are able to provide these kinds of really detailed identification services to whoever needs them. So I'd known Alan Pipe over at the Museum of London for quite some time, and he contacted me to say that he got a box of something unusual that he wanted me to look at. And he said it was from a human grave which had been excavated over at St Pancras, and I arranged for him to come in. The day that he arrived with this big box of stuff, I was busy, he was busy. He left it on my desk. We parted, and actually it wasn't until the next day that I took the lid off the box, and my goodness me, it was just such a surprise. It was a fantastic surprise. Now, fortunately, given my my background, believe it or not, before I joined the museum in 1992, I used to work with archaeologists traveling around, looking at the bones that they excavated from sites and identifying those, both human and non-human. But with my work at the museum, I'd started to specialize in the identification and analysis of marine mammal remains. And looking inside this box and seeing these huge bones, a light went on in my head. I'd worked about 2 weeks before I'd seen that box of bones with the skeletons in our research collection of seals, sea lions, and most importantly, walruses. And that was the thing that made the connection. The bones in the box looked very, very similar to me, to the bones of a walrus. And of course, what a huge surprise that was.
And I think this is a really lovely kind of a combination of the kind of the intuitive side of your initial gut reaction being like, walrus, and then kind of the methodical confirmation of that using kind of the reference collection and stuff like that. And it's a really nice kind of combination approach.
It is. It's something that through training, through intuition, through working with great reference collections, you are able to recognize the shape, the size, the form, and the general function of certain types of bones. Marine mammals, particularly with the seals, sea lions, and walruses are so extremely adapted. I was able to work through kind of a process of elimination, if you like, those species which it might likely be, and those species it wouldn't be. I went straight into the research collection. Actually, the first cabinet that I opened, and the slides you can see now shows you one of the cabinets that I opened, contains the bones of the walruses that we have in our research collection. Now, these bones laid out in these drawers, we have them in our collections specifically for the purpose of being used for science, being used for identification, being used for a range of different purposes by experts inside the museum and outside the museum. And what you're looking at on the screen now, in the top drawer, you're looking at the bones of the forelimb. So that's basically the arms, if you like, of the walrus. And in the bottom drawer, you've got the hind limbs. It was very, very easy to match the bones that have been brought over from the St Pancras excavation with the skeleton that we have in our research collection, that particular skeleton. But actually, one thing that surprised me was the bones of the animal that have been found at St Pancras were actually significantly bigger than anything that we have in our research collection, which is, over 250 years old, part of the collection.
And this is another really kind of satisfying kind of connection in the story, which is that this kind of identification service that the museum provides and that you were doing at this point, it would be impossible without the kind of expertise that we have at the museum and the collection. It's with both of those that we can really solve puzzles like this.
Yeah. I mean, the research collection at the Natural History Museum, it's 80 million specimens. That's across all of the life and earth sciences. We have a wonderful library as well to back up the research collection. And it's one of the best collections, I would say the best research collection of its kind in the world. It allows us to do a lot of very detailed scientific analysis using very traditional techniques in some cases, but also in other cases we use more modern scientific techniques, investigative techniques, which I can talk about a little bit later on.
Yeah, and so the title and the cover image of the show might have tipped off a lot of our viewers to kind of the story this far, but it doesn't stop here, because we're still left with the puzzle of what chopped up walrus bits were doing in a grave full of dissected humans.
Yeah, we're looking at the remains of somebody's dinner, sushi. I don't know. It's fascinating, actually, but when I realised what we were looking at, and given the context, and because of the origins, if you like, of the Natural History Museum and the collections at the Natural History Museum, it made me think about the development of medical science in the 17th and 18th centuries, the development of anatomical sciences, life sciences generally, where scientists were becoming more and more disciplined in the way that they looked at different groups of organisms and categorized them based on their form, based on their shape, based on the way that they lived. They were using what we call comparative anatomy collections. They built collections of different organisms so they could compare between them and look at the similarities and the differences and make those comparisons. Now, it happened with medical science. We know that there were doctors in the 18th and the 19th centuries through into the 20th century who were actually building their own comparative anatomy collections. So you may have a particular doctor who's a specialist, say, in lower limb anatomy. That's the anatomy of the legs. That doctor might want to collect the limb bones of a marine mammal, of a bird, of different organisms that live and move in different ways, to compare the shape and the structure of their bones with the bones of a human. All of these things give you a greater understanding of human anatomy and how to treat those individuals. So my feeling was that we were probably dealing with a collection, or part of a collection, a comparative anatomy collection that had been put together by a doctor, a surgeon, and then at some point in that individual's career, maybe they left and their collection, which was probably littering the table in an office somewhere, were thrown into a conveniently open grave.
So this was just a bit of spring cleaning. Oh, we've got all these random chopped up bones lying around. Let's just put them in an open grave.
Yeah, most definitely.
Grisly. So do we think we know kind of where and who these bones might have come from? Phil or Richard, either of you?
Well, as part of the project, we did do a little bit of research and found a reference to a dissection of a walrus conducted by Professor Richard Owen in 1853 at the Royal College of Surgeons. Now, Richard Owen had taken over as the conservator at the Royal College of Surgeons in 1849 on the death of his predecessor, William Clift. And
Richard Owen, he has a kind of a personal connection to the museum, to the Natural History Museum.
Yeah,
Richard.
He was one of those great comparative anatomists that I was talking about just now, and in fact, he's considered to be the founder of modern comparative anatomy. And as well as his career at the Royal College of Surgeons, he was also the first superintendent of the natural history collections at the Natural History Museum at South Kensington. Now, the thing about Richard Owen, he started working at the British Museum in around about 1856. And when the collections at the Natural History Museum were part of the British Museum, he was in control of those things. He had an open agreement with the London Zoo. He wanted first refusal on any of the animals that died at London Zoo. So he could take the carcass, do a dissection, make an examination, look at the soft tissues, and for him, more importantly, look at the skeletal structure of those animals. It's interesting because his work is so detailed, so professional, and so held in such high regard. I still use his reference works. In fact, one of his reference works that I use, I've got my own copy, Owen's Anatomy of the Vertebrates.
Oh,
there's a three-volume set here that was written in the 1860s. And in this volume, volume 3, there's actually a really very detailed and beautifully written and illustrated section which talks about walrus. And you can see on this page the skull of a walrus there with the very distinctive tusks. Owen goes into a huge amount of detail about the anatomy of these animals. And I started thinking, well, maybe there's some kind of a connection here.
It's a wonderful kind of it's a wonderful kind of tribute to Owen's skill and knowledge as a comparative anatomist that a book that was written 150, 160 years ago is still used as a reference for anatomy.
Absolutely. Yeah. I mean, he was really formative in the development of the natural sciences as we understand them and study them today. You know, as a biologist, a taxonomist, anatomist, paleontologist, he was incredible.
So, Phil, do we think that this could be a walrus and people that Richard Owen was involved in dissecting, or that, you know, the remains might have been part of his collection, or is this just kind of a kind of tangential connection?
Well, there's circumstantial evidence which we probably need to look at more closely. For example, we know that the specimen that Owen dissected in 1853 had come from the Zoological Society of London, and in turn they had acquired the animal from Captain von Peterhead, who had been hunting seals at the Norwegian archipelago of Svalbard in the Arctic Ocean. So that's you know, that with the provenance of that animal is an Atlantic subspecies.
So the situation we have is that we know that Richard Owen dissected a walrus that was hunted in the Arctic in 1853, and around a similar time, we're getting these remains in this grave of a large walrus. Do we know anything more? Can we pick that apart, Richard?
Yeah. Well, these doctors, these surgeons, these scientists were they put out feelers for people who were traveling around the world to bring them specimens for their comparative anatomy collections, and in some cases, they even made the journey themselves. You know, we need to look at the kind of the identification in a little bit more detail, because although we were able to say, although it was possible to confirm the identification of the bones of this animal from the grave at St Pancras as a walrus, what we're not able to do is say whether it's an Atlantic walrus or a Pacific walrus. And for clarity for people, there are two what we call subspecies, two forms of walrus which are recognized by researchers, the Atlantic walrus and the Pacific walrus. Now, the Atlantic walrus is somewhat smaller marginally than the Pacific walrus. The Atlantic walrus tends to have shorter tusks, a slightly more flattened snout, but without really a lot more of the anatomy to be able to examine visually, it wasn't possible, and it's not possible to work just from the limb bones and say it's definitely one or the other.
And I should point out here that in this image, the one on the left is a bull, a male, and on the one on the right is a cow, a female. So even though they do have different sized tusks, this isn't the different sized tusk between the subspecies that Richard is talking about.
Right, exactly. So it's possible to do more investigation, and potentially something that we could do is do a little bit more work with those bones from St Pancras. It would be superb if it was possible, and this is something that Phil and I have been discussing. It was possible to get access to those bones, take some samples from the bones, and then see if we can extract DNA. Now, this sounds certainly 20 years ago, when I was still, just finding my feet at the museum. It was still pretty much science fiction to be able to work with old material and get that kind of information. But now it's a routine thing. It's something that we do here at the Natural History Museum on a daily basis in our own DNA labs. The research collections that we've got here are used by scientists using those traditional techniques, like the techniques I use for the identification. But the more modern techniques for analysing the DNA from those bones, it's a fairly routine procedure.
It's great the kind of the further information we can get using new technology on old specimens. It kind of emphasizes the value of these historical collections, because you never know what kind of information you're going to be able to get in the future with techniques that we don't have now.
Exactly.
And on the subject of what information we can get from the walrus remains, we've got a question from one of our viewers, Jade, who's asked, from the bones that we have of the walrus, are there any clues to how the walrus died? I guess working with such limited bits of walrus because you didn't get the whole walrus. Is there anything you can learn from that?
One of the things that you always do as an osteologist, as a bone specialist, is, as well as the identification, you do a sweep of the bones. You look for any signs of disease, of trauma, any injuries, any potential for cause of death. There's a possibility that could be recorded in the skeleton, but there was nothing picked up. I didn't pick anything when I looked at those bones now.
So the next stage in kind of unraveling this mystery might be to do some genetic analysis on these bones, see if we can get enough genetic material to amplify and to identify which of these subspecies it would be. Because I guess if it turns out it's a Pacific walrus, it's unlikely to be the walrus that Richard Owen dissected, because that was an Atlantic walrus. But if it's an Atlantic walrus, it could be the same walrus.
Yeah, it's interesting though, because there are parts of the range that the Pacific walrus and the Atlantic walrus occupy, the general kind of geographical range, where there's a slight possibility of overlap. And, they could and do very occasionally interbreed. And so that causes problems with the genetic analysis. But generally speaking, the genes will be distinct enough, the DNA will be distinct enough for us to be able to make that determination if the bones are well enough preserved.
Funnily enough, you've just answered a question from one of our viewers that I was just about to ask you about whether the two subspecies can interbreed. And I guess, when you're trying to put kind of delineated categories on subspecies or things like that, we're trying to put things into a box that they're not that clear cut in real life. Biology, especially kind of genetics, it doesn't necessarily fit into the boxes that we might sometimes like to make it easier to study. So we've got a couple more questions from our viewers that I'd like to introduce now as well. One is about walruses. No, I'll go to the CSI question first. So Victoria is asking, could you work out where which ocean the walrus had lived in through chemical analysis, for example, like isotope analysis, by looking at the kind of chemical makeup of the water it lived in?
Yeah, Victoria obviously knows her onions, because stable isotope analysis is a big part of what we do now at the Natural History Museum. It's a wonderful tool. If you imagine where you are in the world, the things that you eat, the things that you drink, you absorb different types of carbon, different types of nitrogen, different types of oxygen, and these are all absorbed into your tissues. It creates a record of where you've been and how you've fed through your lifetime. And in some cases, we're able to take samples and read that information, like reading a book or reading through a slice of a tree when you're looking at tree rings, things that are laid down, the way that the tissues are built, that information can be recorded. So to answer Victoria's question, it's a very strong possibility that we could do that.
And Phil, or this is possibly a question for both of you. This is about Richard Owen. Did Richard Owen also work on extinct specimens like fossils and stuff? What did we know or think about kind of prehistoric biology then?
Owen is the scientist who invented the word dinosaur. He's known more, actually. He's probably more famous for his work on dinosaurs than he's on his work with living species. But actually, it was the work that he did on the living species and the observations he made of living animals that allowed him to make all of those interpretations about how these dinosaurs may have moved, the sizes of them, the kinds of groups of animals they belong to, the different categories. It's incredible that he was able to do that work at that time, but he did. And he really laid the groundwork for the study of paleontology, the study of fossils as we know it today.
And what a legacy, without Richard Owen, we wouldn't have the Natural History Museum.
Yeah.
So one thing I really love about this story is all the kind of connections that it draws out. So, there's the kind of collaboration between archaeology and kind of natural science and the kind of humanity and science side of things. We've got the gut instinct versus the, not versus, but collaborating with the systematic kind of confirmation of that. We've got the new technology potentially being applied to kind of old specimens to get more information out of them. There's a lot of kind of dualities in this story. Is this it must be quite a common thing for osteologists and anatomists to work with archaeologists?
It absolutely is. Yeah, I mean, I really relish working or getting the opportunity to work with people like Phil, colleagues in archaeology. And Phil will be able to say more about this than me, but just to kind of contextualize it from my perspective, we have collections at the Natural History Museum of groups of organisms and minerals and everything that we are able to study in the natural world that have been catalogued, categorized, identified, examined to the nth degree, but there's always still more work to do. And one of the key things about our collections is we're able to look back at how different organisms have actually evolved and adapted to their environment, to their lifestyles over time. And if Phil and I are able to do more work on the bones of the walrus from St Pancras, it's not just about coming up with an identification, a positive identification, Atlantic or Pacific. It's actually looking potentially at how much has changed in the DNA of the walrus from that region, whichever region it is, over the past 150 years or so, what we call genetic diversity. That changes through time. And loss of genetic diversity is a bad thing because it puts a species or a subspecies at risk. Now, by being able to have those information, you can actually help conservation planning of different groups of animals. And that's a really key thing. And that's one of the key things that the Natural History Museum is involved with. And it's specimens like the kind of material that Phil and his colleagues are able to provide through archaeological excavation that allow us to go back in time and look and see how far those changes reach.
Yeah, and it's interesting that you say that this walrus was kind of unusually large, because a lot of the time when you get animals that are hunted by humans, over time you do sometimes see a reduction in overall size, because human hunters will often go for the biggest and most impressive individuals. So things like bison and longhorn sheep and maybe walruses. If humans are hunting the biggest ones, then it's going to be the smallest ones that survive and breed, and so the next generation is going to be a little bit smaller each time.
Absolutely, affecting the gene pool, removing the genes for large size. It's what we call, and something that we're studying very, very closely and in great detail, again at the Natural History Museum, the effects of the Anthropocene, that's the effects of humans on the planet. How far back do those effects reach? When do you first see in the fossil record, or the archaeological record, I should say, the presence of humans and the effects of us and our presence in the environment and the way that we start to shape and change things? Absolutely critical to have that information.
And Phil, what's this kind of collaboration like from the archaeological side?
Well, it's very, very exciting. I think when you get the sort of interdisciplinary sort of collision of ideas, that's when real innovation happens in science. But another aspect for me is the archaeological charting of exotic contact with remote regions of the globe. Through the archaeological record. So we're seeing in a densely sort of urbanized cemetery evidence of the effects on the human body in that sort of urban environment, industrial and sort of close sort of density of population.
And I guess it's great that the dates are so well preserved on these as well.
Sorry.
Oh, sorry, I didn't mean to interrupt. I was going to say that for that purpose, it must be great that the dates and the nameplates are really well preserved on these particular specimens.
Yeah, I mean that chronological resolution is absolutely vital, because we're able to then sort of correlate that with what's going on in the wider world. So for example, James Cook going up the Bering Strait on his third and ill-fated voyage in 1776 and contacting the Pacific subspecies of walrus, and then specimens being brought back to sort of zoological collections in Europe as explorers go up into the Arctic. That Richard may be able to expand on that.
Yeah, we it's this great sense of continuity too, because there were archaeologists working and bringing collections to the Natural History Museum, to the British Museum when we were there, and to the Natural History Museum back in the 19th century. Archaeologists still do that. The connections that Richard Owen had with London Zoo, and the fact that he had this ability to request the carcasses of animals that had died to further his scientific knowledge. We still have that relationship with London Zoo and other zoos around the country that gives us an opportunity to continue our studies and actually continue to acquire material for our research collection. It's all about laying foundations. Science is a constantly changing and evolving subject. It's about carrying out an analysis, presenting your results, and then presenting those results to the wider community, waiting for people to come back and improve upon those, because invariably they will, and that's what happens. It's all about change. It's a really exciting subject, but it's a very interdisciplinary subject, and this is one of the things that I love about it the most, I think.
Yeah, I think something that you've both mentioned there is how exciting it is when you get a different set of expertise and a different viewpoint looking at the same kind of work, and often drawing totally new connections. And personally, as a Londoner, I love the fact that this is such a London story. It's got the British Museum, it's got the Natural History Museum, it's got St Pancras, it's got London Zoo, it's got the Royal College of Surgeons, and it's all kind of all not that far from each other.
Yeah, all these institutions are within spitting distance of each other. All the teaching hospitals, the anatomy schools, the veterinary college. So yeah, a lot of the key players in these institutions would have known each other quite well.
One of the things I'd like to say about that, we have this great expertise historically in these institutions. We have great expertise right now in these institutions, and one of the things I think that's very different about how institutions like the Natural History Museum is from, say, the 19th century, early 20th century, is we have a really diverse workforce from a whole range of backgrounds from all over the UK, in fact, all over the world working here. And I think that's part of the richness that we have to be able to work with colleagues from a variety of different backgrounds. Science is a much more open subject than it was. Science is for everyone, and that's the thing that we need to point out.
Yeah, and the more kind of diversity of experience and viewpoint and expertise and kind of personality that we have in the field, the richer it makes it for everyone, and that can provide more knowledge and more benefit for the whole of society.
Yeah.
And my favorite thing about this story is that it's still ongoing. There's still more to find out, which it's a very science thing. You answer a couple of questions, and then it pushes forward the boundary of what there is to further find out.
Hopefully people are enjoying this as much as Phil and I did, and still are. But this is what it's all about. There are thousands of stories like this that we could tell. My own time at the museum, I've experienced an awful lot, and my colleagues who've been at the museum an awful lot longer than I have. It's the opportunity to be able to reach out and work, make our collections available, make our expertise available, and form these links with experts in other disciplines that creates this great wealth of scientific knowledge, and hopefully inspires people to become archaeologists, museum curators, other types of scientists. But that's what we need. We need to inspire people to work in science in the future.
Well, whether it's anatomy, archaeology, genetics, or any aspect of kind of science or research, or finding out, pushing forward the boundaries of our knowledge, I think it's always going to be really, really fascinating. And I think that's actually a really nice place to leave it. Thank you so much for joining us. I've had an amazing time. Thank you so much for sharing your stories. This has been great.
You're welcome.
Thank you.
And thank you at home for joining us today as well. I hope you've enjoyed it as much as I have. Do join us every week for Nature Live. We have shows on Tuesdays at 12 and Fridays at 10:30 in the morning, GMT. The museum is currently closed at the moment, but as soon as we're open again, we're working very hard to make it a safe and enjoyable experience for everyone. So do keep an eye on our website for details. For details of upcoming shows, you can check out either our website or our social media channels. We're on Facebook, Instagram, Twitter, and Periscope. But until then, till next time, that has been Nature Live. That was Phil Emery and Richard Sabin. I've been Khalil Thirlaway. Thank you.